Hello, this is the second multimeter I had many years ago, I think around 15 or 17 years ago. Yes, probably 17 years ago. And I would like to show to you why this multimeter was not the meaningful upgrade I hoped from this multimeter that was my first digital multimeter, the Unity M840B. So let me tell you a bit about what were my expectations. I found out that the Unity I previously had some issues with accuracy, and there were clearly some situations where I would have liked much more features. The first aspect, of course, was accuracy, and I was particularly hopeful of the fact that this multimeter will have an improved accuracy. But unfortunately, as you will see, this is not really the case. Another aspect I was particularly interested in was the ability of the meter to have various readings, such as an alternate current measurement, so an ammeter for alternative currents, and also the capacitor test that, as you see, can go as high as 200 microfarads. Of course, the ohmmeter range was increased to 200 megohms. On the other side, this one is limited to around 2 megohms. 2000 kiloohms means 2 megohms. So this was the limitation that I noticed with this multimeter, and I hope that this one was better. And of course, the ability for it to handle currents that were much higher, 20 amps. So I was having a lot of hope with this multimeter. Unfortunately, it was misdirected because the platform was still similar to the old ones, and in most cases the calibration or the accuracy was not that much better. And even if it had a hold function, in practice it was not as useful as I was expecting it to be. Alright, so let's look at the meter, but first let's make the same test I made with the old multimeter, and that is using a battery that is almost depleted to have a voltage measurement. As I have seen, with such a low voltage, this meter is going to shut off very quickly. But before that, it will have the ability to have at least some sort of attempt at measuring this 1.5 volts battery. Alright, so I will prepare the contacts and make sure that with the available hand, I will press it and see. Okay, no. No. Okay, so over 2 volts. As you have seen clearly the one sign, let me make an attempt at doing the same on the 20 volts range, just because I want to show to you how far off the reading is. Just a moment. So 2.7 volts. Yes, I was expecting more than 2 volts, and this is particularly because this meter doesn't have a self-adjusting capability when the battery gets lower. And this happens with a whole class of multimeters from this range, and they are still available on the market. However, this is horrible for persons that want to have accurate readouts. And the same issue you have noticed on the voltmeter range, I'm pretty sure it also happens on the ohmmeter. So you're going to see a lot of impact from just having a battery that doesn't have the required voltage. And since those readings are dependent on the voltage of the battery, it means that even a slight deviation from the voltage you are supposed to have, I mean, you are having a 9 volt battery and you are drifting towards 8.9, 8.5, and so on, means that subsequent readings for the same device are going to be off, or for your batteries or for anything else you want to test. Which means that the device is very poor in terms of accuracy and reliability. However, interestingly, you're not going to find out this mentioned anywhere on the documentation. So let's look upon the documentation and also what's included in the box. You can see the probes. Let me tell you that they are clearly better than they were on the first multimeters. As far as I remember, they are better than the ones that were available on my first multimeter. These ones, I think, can also be serviced. The ends could be pulled, and you could solder again the wires if they become loose. So the probes themselves are not great, but I think they have a much better survivability than the first generation had, and you also have a temperature probe. However, as mentioned in another situation, temperature probe is highly inaccurate because it is superimposed on the contacts and the circuit that also features an internal I think thermistor, no thermistor, an temperature sensor that I think is of the silicon type. And when you are actually placing your probe, you are placing it in the same circuit with the one that is inside. So you're not going to have a very good accuracy, and this will probably mean that a couple of not necessarily degrees, I think that part of degrees Celsius is not going to be the accuracy that you have with the internal one and with the external one. So calibration is going to be dependent on which value you want to be the most accurate. So it's not going to be that great in this respect because you're actually making a compromise, and the calibration, I think, is going to also be dependent on battery, but we will check to see if this is right. So let's go on the temperature readout, and yes, 80, which is actually impossible. So as you can see, it's also dependent on the battery, which is a horrible design, and this has been the case for 20 years. And remember, these devices are still available on the market, and I'm pretty sure that the circuit is the same. So it's a horrible accuracy for multimeter. And this is one of the reasons why digital multimeters, despite having more features, may be sometimes a lot less reliable than even cheap ones like you see right now. So the YX360 series, that doesn't have a great precision. However, it will never show you this type of inaccuracy. It will be much more consistent, measuring the same circuit or device or component than such digital multimeters will have. And probably this is one of the reasons why professionals and other persons that were hobbies were not particularly fond of digital multimeters. All right, if we look at the specifications, let's see if we can find, okay. So, if you look closely, you're going to notice an accuracy that is going to be specified, DT9208A, 0.5% in the millivolts range, 200 millivolts range, 0.5% plus minus 2. This is actually impossible. As you have noticed, those readings are far off this accuracy range when the battery is having a very low voltage. So I think this goes on to show that it's pointless to have these specifications when you don't have any compensation for that. AC voltage, yes, 1% accuracy. In general, 1.2 for the higher values. Again, if you're looking at specifications, you're seeing a decent device. Unfortunately, as mentioned, this is not the case. DC amps range, 2% accuracy. On the 10 amps range, you notice the fact that it's 10 amps and there is a mention of 20 amps. I'm pretty sure that the device can measure higher currents, but it's going to be horribly inaccurate. All right, we are moving further. And we are seeing 1% accuracy, 1%, 2% accuracy for the AC current measurement capability. And the rest of the specifications, as you can see over here. All right, frequency tests up to 400 Hertz, so it's not very high accuracy in terms of using it as a frequency counter. Precautions and preparations, yes, nothing particularly interesting. Resistance measurements, diodes, okay, the testing, the surrounding temperature, the limit temperature, 250 to 300 degrees Celsius for a short amount of time, resistance measurement. Oh, and I should have mentioned something about the capacitor testing capability, so 4% accuracy at all ranges, which is actually pretty poor. I'm pretty sure that there are other devices that have much better accuracy, but this is not one of them. And for the resistance measurement, or for the ohm meter, 1% accuracy across most ranges, and even less so for the 200 megohms. So really not a very good device. All right. What else could be said? Well, in general, if you're going to look upon these specifications, you are already thinking about a good device. Unfortunately, this is not the case, and as mentioned, it was a poor purchase. However, back then, there weren't many devices that you could find on the market, and this was one of the ones that were more readily available. All right, let's see what the build quality is. We are having a rubberized casing, which feels quite nice even after all these years. I think this is one of the good design features of this product. You have the back cover, of course, which is screwed in 3 places. Good and bad. Bad when you have to replace the battery. Good in terms of the ruggedness of the device. You have an LCD that can be tilted, and this is one of the gimmicks. Oh, sorry, I have to push this button. Okay, and it releases the latch. So you can have, this is one of the features that you're not going to see in most modern devices, but I still don't see that as being particularly useful. And if you're taking the cover off, we are going to see a design that is quite bare. I think that most of the components are on the other side of the board, and as they seem, some of them are placed like typical components, like soldered components. Other may be SMDs, so a slightly improved design. I can see over here a variable resistor that could be used probably for various calibrations. And that's just about it. This is the connector, the ribbon that goes towards the front screen. The buzzer and the fuse. Of course, you can see the fuse for the 250 or so milliamps range, probably 200 milliamps, yes, so probably the resistor, the fuse is rated at 250 milliamps. The resistor that has a very low value used for high current measurements, and you don't see any sort of other fuse being used for protecting this circuit in case the maximum current gets over that value. However, if I'm looking at this resistor, I can tell you clearly that this is a resistor rated for less than 20 amps. It's probably for 10 amps. Even if it mentions over here maximum 20 amps, and I think it's just for a couple of seconds. I don't know how many it's specified in the manual. I think that it's horrible to have this device as a reliable emitter in such circumstances. The battery, of course, as mentioned, this is not the right battery. It's one that is depleted, so I will take it out. Okay, it's slightly bad, and as you can see, the connector can be slightly damaged in time, which shows that it's not a particularly good design. Okay, let's place a reasonable battery inside, and let's see how the device behaves. I think that this battery has around 7 or 8 volts. Let's see. I'm going to use a classical analog meter and see what this device shows. Okay, minus plus. I think this is the correct polarity. at 9 point something volts, so it's quite good in terms of the voltage being delivered. Alright, so let's place again the cover and let's see what the device is capable of. Alright, so it's powered. Now let's make some measurements. 25 degrees, which I think is a bit high for my expectations. I think that the temperature is closer to 22, yet the device doesn't have a very good accuracy. Probably it could be calibrated in a different way, or perhaps it was slightly warmed by my hand. Let's find out which one is the correct. Okay, let's see, MAK. So MAK, which means that I have to place it K plus, K minus. So these are the thermal probes. K minus, K plus. Of course, the connections are horrible in the sense of quality. 25. I'm pretty sure that this is not a correct readout. As you can see, it increases, but my hand is clearly warmer than 26 degrees, sorry. Yeah, so the accuracy is quite poor. And even if I'm placing it somewhere else, and I was expecting at least a 30 degrees, this doesn't happen. So you can think right off the bat at having very poor accuracy in this range. Alright, so the thermal probe is again more like a gimmick showing you the general temperature you may be expecting. Alright, let's place the probes again and let's make some measurements. Alright, our 1.5 volts battery will be the first test. 2 volts, okay, let's see. I'm placing the battery. 1.524. This reading is quite accurate and quite close to what we have seen with another digital highly accurate meter. So I think that the reading is probably good enough. I think that I have calibrated the device some time after I purchased it, so that it was quite reasonably good when testing those batteries. I think I tested with a known good battery and then try to have a reading that was as consistent as possible. So I think that this goes on to show that such devices were never the ones that you would work with immediately and have everything set up for you. Again, it's a cheap device and unfortunately it doesn't behave that great. The rotary switch feel is quite poor. I mean that it's quite mushy, and this does not instill a lot of confidence. Okay, let's also make a resistance measurement, and we are taking our typical variable resistor and measuring just the fixed part of it. So I think around 0.4 ohms, let's see. Yes, the whereabouts, it's quite a good readout. And let's go and measure currents. So we are going on the 20 amps range, and I'm placing the probe over here. And let's see how much current this battery delivers. I'm expecting much more than the previous meter showed. Oh. So let me check again. 20 amps, okay. And a common, and how much? 0.4. That is not possible. 0.3. Sorry. It's alternative current. You can see that the color is similar in both cases when it shouldn't have been. Anyway, my mistake for not using the proper range. 1.64. That is quite poor. I was expecting much better. 1.67. Yes, so actually the current measuring capability of these meters is poor, and it really doesn't fare any better than this, the short circuit one. And I can tell you clearly that the batteries can deliver much more because whether we are talking about analog meters or digital ones, they consistently show a much higher current reading. So this device is clearly poor in this respect, and there is no way to sugarcoat that. So overall, yes, I think it was a poor device, and unfortunately it was one that didn't meet expectations. It was a minimal upgrade from this one, since it had a slightly better accuracy in certain situations. It was not as consistent as I would have hoped. Although it had much better ranges, the accuracy was not that great. So the venerable UT43C that you have seen on other videos is most likely a very good contender that has very similar capabilities. So it wasn't the upgrade I was hoping for. And unfortunately, this went on as being relegated to the dustbin a bit after the first one. So ultimately, even if I still have it in my collection, I think that it's something that I will not be keeping it on the long time. And of course, I am not recommending you purchase such a device at all, because even though it costs much more than this multimeter you may still find on the market, I think it's a poor choice. It has the same measurement capabilities, it has the same pitfalls, and it's not great in any respect. So I think that you should be totally avoiding these models. If you want to have a good entry-level multimeter, I think the UT43C is still good, although I would suggest you to buy the Plus range or something similar from other manufacturers, because they offer much better capabilities. I think it's a good choice not to look for 2000 count multimeters, because this means that you are having exactly the same technology that was developed before, and the same pitfalls that you notice over here, even on the UT43C. And I think that if you are more into electronics, you should buy a good multimeter. You may have poor multimeters just in order to have a better understanding of what the market offers and how some things can go wrong in the ways of design. However, I think that much better multimeters are on the market, and you should strive for that. If you want a cheap one and you're using it only in certain situations, I don't see a problem for you to purchase such a model, but clearly this one is both big and doesn't offer any additional advantages to the smaller ones. So I think that there are very few